produce chemicals, right? So and that's right. So that's like our byproduct. So and specifically, we're focusing right now on lithium biomining. So developing a product that can basically go in and metabolize lithium like ore, and then extract like lithium from very hard to obtain sources. That's like currently isn't feasible, right?
This is another episode of the Form Your Own Pack podcast. I'm here today with Benjamin Alva from Maverick Bioworks, and Benjamin is one of the first nominees by another podcast guest, which was Furkan, who nominated you. So Ben, thanks for joining me. And it's Benjamin, I'm sorry.
No, yeah, thanks for having me. Yeah, it's great.
So for people that don't know, who is Benjamin and what's Maverick Bioworks?
Yeah, so I'm a bioengineer, specifically cellular and molecular bioengineering, but I have expertise kind of across the board. And a lot of my work has been in synthetic biology applied to space and environmental research. And now I'm at Bioworks. We're looking to develop a platform that makes enzyme development and organism development cheaper and faster to replace traditional industrial processes by making them more sustainable and economical from an array of different factors.
Oh, wow. Okay, that's crazy. All right. So there's a lot to unpack there. So I guess the first thing is, what was the motivation for starting Maverick?
Yeah, so we actually started with me coming together and forming this group called the Microalgae Bioengineering Initiative, where we wanted to save coral reefs from coral bleaching. So basically taking the organism that lives inside corals, this algae, and then modifying it through genetic engineering, directed evolution approaches, and making it much more resistant to the high temperatures and the high solar radiation. And we developed this platform technology to do this. We're like, okay, we're missing a lot of the tools because the field is very much lacking equipment and the ability to combat this, given this will be the first great catastrophe of climate change. Within the next 50 years, almost 100% of them will be wiped out. So
Wow, really?
yeah, it's intense. It's like, yeah, it's been able to wipe out, like I think around 25 to 50% of all like fish reserves on the planet, right? So which it'll be like devastating, is already current. So we developed a platform to allow us to engineer these organisms at a much higher throughput and culture them as well, given that culture technology was very minimal. It's still very minimal. We're like, okay, like we're working on this problem, but like I think we have many more things that we can apply it to. Like, right, we can make other type of organism engineering, especially organisms that are like their functionality or the feature you want from them is very unknown. And we can do this, and we can like learn in an automated fashion. We can engineer these new strains to do what we want them to do, right? And not just for the environmental applications, but then to replace different industrial processes that are currently very like produce a lot of waste or use high amounts of energy and are just generally not sustainable for the future.
So when you'd say platform, what for people that maybe don't know, what does that mean in this industry?
Yeah, definitely. So that refers to your like robotic or machine system or some type of your technology that's making your product, right? That's going to be developing. It could be either somewhat manual or it could be automated, but generally it's like your pipeline for product development. And that's what kind of the colloquial term that we use to kind of characterize in the biotech sphere. What is our system of making what we want to making our products.
So what are some of the applications? Like first of all, have you built your platform out?
Yeah, so we built a prototype of it previously, and then getting the Y Combinator. Now we're developing the full-fledged functional version of it, right? So we kind of tested the technology to make sure, right, yes, like this is something that's like feasible, like before getting the Y Combinator, and then now we're taking it to like this, like there's like 5 foot by like 4 foot like device, right? It's like it's
Okay.
huge on the table to perform all these procedures in automated fashion, and with all the machine vision like analysis of it as well. So it's yeah, so it's coming along. We're kind of around maybe I would say 1/3 of the way through developing this current version of it. So yeah, by demo day we want it to be completely done.
I was going to ask that because so Y Combinator is typically a 90-day cohort. Are you able to complete this new version in 90 days?
Oh yeah, yeah, most definitely. And it'll still be in more of an MVP state. And then after right after demo day, we'll like refurbish some of the things, the features that we want to add to it, rather some of the yeah, different aspects of it that we can modify and improve, and we'll have that all mapped out. But by demo day, I have like a week long, like these week sprints essentially, and that we want to develop these features. And pretty much we're at least how I've planned it is we're developing each of them in a very modular fashion. So we're building out like first like the entire frame, the kind of the axis movement, and then developing say the this like culturing, like this thing that shapes cultures to make them grow better. That's something, it's a piece that you can put in this like mutagenic, this source that mutates them to develop the different like to generate all these different types of organisms with different like genomes, right? And then we screen them. So that's another system. And then putting it all together, and we have the most critical ones in the very beginning. So by the time in the next like 2 weeks here, we'll pretty much have a completely functional platform. And
Wow.
then because we'll prove it, you're right. And then after that, we'll just be adding more functionalities to it to make it better, like climate control, sterilization control, as we go out through the week. So pretty much like we're showcasing that like the full-fledged version will work, and we're just pretty much enhancing it all the way up to demo.
So in this case, like when you say it will work, what do you produce that demonstrates that it works?
Yeah, exactly. So an enhanced organism or enzyme. So like basically a bio, like that's kind of our target of bioproducts is either an enzyme that can, like it's a catalyst of some kind of reaction, or an organism that is itself a catalyst but can do a lot more things. It's like itself, it's a biosensor. It metabolizes more complex pathways. It's basically a little cell factory to produce chemicals, right? So and that's right. So that's like our byproduct. So and specifically we're focusing right now on lithium biomining. So developing a product that can basically go in and metabolize lithium like ore, and then extract like lithium from very hard to obtain sources. That's like currently isn't feasible, right? Because like Texas has a huge reserve of them, like a massive reserve of lithium. In the sputamine-based rock, which is a special kind of ore that contains lithium, and then we're designing a mechanism to basically mine that, because there's going to be a huge shortage of lithium, right, going to the future, because
Huge,
demand's going
yeah.
to skyrocket, right?
So it's interesting because I mean, a lot of the narrative, this is really interesting that you've chosen that, because let's say, you were thinking Tesla and all these other EV car manufacturers, and lithium is a primary component in making batteries. And kind of the part of the narrative is that the actual lithium mineral is coming from sources that are not in the USA, for example. But what you're saying is that part of that is because in Texas, for example, has a large deposit, but it's not easily acceptable or accessible. How does the bioorganism help pull that out?
Exactly. Yeah. So currently it is inaccessible, right? There's a huge amount of it in Chile, also in like Mongolia. China has some reserves as well. But so right now it's in this crystalline rock formation around at like 2.3%, which is high. But again, is almost, you need to have specialty methods of grinding, and then this severely acidic process to metabolize it. So the organism comes in, and basically we're developing an enzyme that breaks down like the silicate itself, so like the rock, and using it like this. Basically, its main activity is that it binds to the rock particles and breaks them down and releases lithium in an ionized form. So like basically like it's literally like breaking down rock. Think of like little like scissors, and then like chopping up pieces of rock and then breaking it down with lithium extraction. Yeah.
So how does it get into the rock? Like, are you injecting it? Are you spraying it? Like how
Yeah,
kind
yeah.
of trying to picture this is really interesting.
Yeah, exactly. Yeah. So we do some mechanical breaking up first, because it's like a huge, like think of it in like that, like a mountain, right? Or not mountainside, but like a large chunk of rock. Break it down into smaller particles and put it in like this reaction vessel. And it sits in the reaction vessel, and then basically the enzymes in aqueous solution are mixing with the rock, and then it essentially like starts to break down from the surface to the interior of these rock particles.
And will you know if this is a feasible approach? Is that kind of the goal, is to figure out like, hey, is this something that's economical, or what's the time frame? Like, can you calculate, hey, this will take a month or a week or whatever?
Exactly, yeah. So we plan to basically get, so a part of our business side as well is to get LOIs for this business. We're getting already traction on, just because right now we're offering our services as a contract research, more or less. It's like coming like contract research. I would say more so as basically a B2B like organism development platform. So you have a solution you want to replace or develop something very particular. Like we've had a lot of synbio companies and other biotech companies already approach us, be like, oh yeah, can you help us, specifically enhance an organism or an enzyme to replace the process? Because our team isn't really strong in those like disciplines. So like we want your help, right? So that's really solid. And then it's working on a lot of things I could go into,
Yeah, that's really
but like
interesting. So
lithium,
it's not just obviously this is just one application you're saying. I mean, this could
this is
be.
like an internal product that we're developing that we want to have like completely our IP, right?
I love it. That is so interesting. All right, so what's next for you guys, and what are you planning on doing after Y Combinator?
Yeah. So what's next is developing, basically utilizing our platform to create products for people within the synbio and biotech industry and other chemical industries that want to expand or replace their current processes, and also further create a partnership with a lithium mine or a lithium within the lithium supply chain and start applying pilot programs with our technology. So we've demonstrated that it is feasible, and there's other like resources out there that showcase like these methods are feasible, but what we're taking in and we're enhancing its capabilities. So we're making these enzymes for lithium biomining better, right? Just like far faster, more efficient, and doing it in an automated high throughput fashion. So next step is partnering with the mine and getting out there in the field and extracting some lithium, right?
Man, that is incredible. What you can just your head just kind of blows up because you're like, this is the center of a whole bunch of stuff that's going on right now that's in a growth, like hyper growth industry. So you're kind of like when they say, make picks and shovels, you're literally in that category
Exactly right.
of a boom industry. So that's really very, very interesting. All right. Well, we will definitely be watching your progress. I want to be conscious of your time, and I'm glad that you spent a little bit of time kind of explaining this to me, who's not super educated in this, but very interested. So I'm gonna ask a couple of quick questions. First up, if you could tell other founders, if you could give them one piece of advice, and only one piece of advice, what would that be? What's the most important thing that you would tell other founders of other ventures?
Yeah. I would say that always be put your nose to the grindstone, like always. So essentially make sure that you're, especially from a biotech perspective, like always try your best to find product market fit as early as possible. That's like people, at least on our side, who are scientists and coming from like who like go through at least the PhD route, they're very much they don't have the mentality to really go. They like, oh, let's design everything behind the scenes. Oh, this is like really cool and novel, and I just want to like work on it. But they're really apt to ignore just the customers, or at least people who they're partnering with in the supply chain, all the stakeholders. So like get that out of the way as soon as possible and before you even start developing technology. I think that's very critical. And then once you do that, then just don't then be very focused on creating what you want to create, right? Because it will take a lot of time, especially in biology. It'll be far longer than anything, even in hardware. Like you're trying to build, like say, some robot, like just like a pure robot, like that's going to take longer to build, right? To build like an organism that in itself is a robot, but it's still living. So there's so many variables that are unknown. But those two stages, discovery and then focus on the tech. So
I love it. And that's consistent with we try to evangelize, which is rapidly prototype and then go talk to real customers.
yeah.
I think you're kind of echoing that. Is there anyone in your Y Combinator class that's building robots, by the way?
I know there's a person who's building like planes, like hydroplanes, which is
Wow,
pretty
really?
interesting.
Okay.
Yeah, they fly over like the water, so it's like they're trying to replace cargo transport with like as opposed to using trucks now, like making, because planes aren't super feasible because they get to
Yeah.
like a lot of energy, but now they just skirt over the water. Um, yeah, which is interesting. And then there's another group who's working on some satellite technology.
Damn.
Um,
Okay. Y
but
Combinator is getting some pretty hardcore stuff. Like we're beyond
yeah,
the age of apps, man. We're doing some exciting things. That's incredible.
yeah.
I love it. What role have partnerships, alliances, or community been in your success so far?
Yeah, so I think a lot from our perspective, before getting into YCon, we were collaborating with a number of people on some other projects that we were developing through our current pipeline around organism development. So we're partnering with the Inter-University of Marine Biosciences in Israel. We have been conducting a few expeditions to go collect organisms, so bioprospecting. So we collaborate with some local officials on the academic and government side, the Maldives government as well. We've been collaborating with to work with their coral reserves, given that 90% of their economy is based off of coral, like right on tourism.
Wow.
So yeah, and then so these partnerships have allowed us to go out there and then do collect samples and to work with them and like also get a huge amount of like, feedback on what we're building as well, and then also help them from a more sustainable and improving like the environment for those different perspectives. And also we're doing some stuff with plastic degradation as well. So we're working with a couple of universities in the United States that really kind of boosted, like allowed us to outsource some of the some like the chemical engineering development and support that we could focus on like developing our automated systems purely to do organism engineering. Well, some of the other things that, because like, even lithium biomining, right, takes a lot of other expertise beyond that. Like you have to build a whole, plant chemical processing if this is like to go to full scale. So there's a lot of expertise that we'll be partnering with and form collaborations going forward.
So I'm just curious, like, do you envision this as like, would there be a version of your gigafactory? Like how Tesla has a gigafactory, would there be a Maverick factory?
Yeah, so that's one of the dreams we have. Yes, it might end up being like it might be easier to just purely have like a mining operation, a very large like corporation like invest and they have them own some of that equipment, right?
That
And
makes
before
sense. Yeah.
we supply the bioproducts, but one of the models is we literally we vertically integrate and we have like our own land and we have our own mine sources and we focus on it if right and then apply our systems to it and then sell it. So like we own everything, right? Like again like the Tesla model or what they're aiming to do. So yeah.
That's super exciting, and I'm sure Tesla may at some point want to talk to you, especially if you have something that's viable for lithium.
We've actually already been talking with some people at
Yeah,
Tesla.
okay.
So,
Yeah, that would make sense. That's totally logical. That's incredible. Well, I'm really excited to see how things progress for you guys, and we'll keep tabs on you. Come back and talk to me anytime. How do people get in touch with you, Benjamin?
Yeah, so you can find us on our website. We have a contact form. And also for me individually, you can reach out to me on LinkedIn, Benjamin Alva, or at my email, benjamin@maverickbioworks.com. Those would be the two best sources.
All right, we will include all those in the show notes, and there's probably so much we could unpack here. I'm really excited to see what you guys come up with. So we'll keep an eye on your demo day as well. The final thing that we'll wrap with, as you know, we like interesting people that join us on the podcast to nominate other interesting people. Who would you, Benjamin, like to nominate as a future guest of the Form Your Own Pack podcast?
Yeah, that's a great question. I would say that this is also in the same S22 Y Combinator batch. He's working on this.
Sure.
David Gomari. He's working on YOLO. It's a company who's trying to expand life, your longevity. So YOLO is making you live more than once, right?
Oh, wow. That's crazy. Okay. So and his name is David? No.
This is Daniel Gomari.
Daniel.
Yes.
Daniel Kumar.
Yeah.
All right. So Daniel, you've been nominated as a future guest, and I'm actually really interested in learning about YOLO. You know what? You know why I said David is because in my head, the name David Sinclair popped in my head. Who's well noted, as he does self-experiments on extending his own telomeres, right?
Yeah.
Extending his own life expectancy. It's pretty interesting. All right. Awesome. I really appreciate your time today, Benjamin. We're excited to see what you come up with, and we thank you for that nomination. We'll look forward to talking to you in the future.
Awesome. Yeah, great. Thanks for having me.
Anytime.